Investigation number 4, kinetic energy, and this is a video that goes with the lab heating and cooling air A and B, and it's page 32. And the question that we were trying to find out doing this lab was what happens to a volume of air when it is heated and when it is cooled. And this is the lab sheet that you can fill out during this video or at the conclusion of this video. And this lab sheet is in your spiral notebook. So the question thrown out here was this one, and I just read that, and I gave you some supplies in class, and I just said, hey, show me what happens when the volume of air is heated and when it's cooled. And that's all I said, and then you went on from there to do some investigating with your group. Well, we didn't really have enough time to, most of us didn't have enough time to get the drawing done and labeled and then explain on these lines what exactly happened. So that's why I made the video for you. Okay, so the second part of this is heating and cooling. Oops, let me erase that. Heating and cooling air B, and that goes along with this sheet. So we'll have this done by the end of this class period as well. So concrete enough for fourth graders to understand just exactly what was going on. So in this video, I'll walk you through 2 different demonstrations, and you can draw either 2 of these demonstrations on page 32 in your spiral. So either one of them's fine. The most important thing is, do you understand the concept and are you able to explain it? So let's just do this first, short video first, and then I'll get back to you. Okay, this video goes along with heating and cooling air A, page 32, that you have in your spiral, or not your spiral, yeah, your spiral notebook. It's pasted in there, page 32, and then heating and cooling air B. And the question, part 1, the main question is, what happens to a volume of air when it is heated? And what happens to a volume of air when it's cooled? So first of all, volume refers to the amount of space that the air is taking up. Volume. The amount of space the air is taking up. And in our tray, and in the classroom, you had access to bottles, some cups, styrofoam cup, and in this container there's some bubbly water, and then I've got some cold water here, and then we had hot water on the hot plate. So what you had to do is come up with a demonstration that would be simple enough for a fourth grader to understand. Okay? So the first thing I thought was just show a demonstration that is pretty simple to show with heating up a volume of air and then cooling it down. So first of all, if I take the cap off of this water bottle, it's completely filled with air. There's millions, billions of particles in there, and they're at the same temperature as the surrounding air in the room. So what I thought I could do is take some of this hot water, pour it into this bottle, and now we've reduced some of the area where the gas would be, the air, because now it's full of water. As I just leave it sit there, it's pretty hot. Right away I can see that the bottle seems to be getting tighter. And you can actually hear it cracking a little bit. And as I shake it, it cracks more. The particles of air in the area above the water are gaining kinetic energy, and they're bouncing around, slamming into each other, and slamming into the side of the plastic bottle, and they want out. And they want out. Okay? So that is one example, one demonstration of what happens to a volume of air when it's heated. This volume is taking energy from the hot water, and these particles are moving around at a faster speed. That's kinetic energy. Kinetic means motion. So they're moving faster. Okay? So if I take this, and I take the top off quickly, dump some of my water back out, cover the top, and then put it into cold water, I have a volume of air, and I'm going to cool it, and I'm just holding it in the cold water, and you can hear it popping a little bit. So right now, the heat energy that's inside of the bottle is being transferred to the cold water, and what's happening is the particles of air in the water bottle are starting to slow down. They're losing kinetic energy. They're moving slower. They're kind of coming in. They're coming into each other. So I could hold this in here longer, and this water is really not that cold anymore, but it's cold enough to have caused the container to smash, to implode. So why is it doing that? Well, we took a volume of air that was heated up from the warm water, we trapped it by putting the cap on, and then we put it into the cold water. Those particles came together, they contracted, and the air particles in this room and the water that was around it pushed in on the sides of the water bottle. The sides of the water bottle were pushed in from the surrounding air because it has more kinetic energy. There's particles slamming into it. And we talked about in class how every square inch of your skin has about 14.7 pounds per square inch. That's a lot of pounds per square inch. So that's a demonstration you could have done. Now, how could we make this expand again? Well, we could put it back in hot water. Couldn't we put it back in hot water and heat up that? So I put it in the hot water. Hopefully it's not too hot so that I'm melting it. I don't think it is. But you can hear it popping already. So the particles of the gas in this volume, in this bottle, are gaining kinetic energy. They're starting to move around faster. And if I leave it in here, it will continue to expand. That means the particles are gaining kinetic energy and they're slamming into the sides of the plastic bottle. So that's a demonstration that shows what happens to a volume of air when it's heated and when it's cooled. Okay, so now you can see that it's taken its original shape again. Okay? Okay, now another demonstration. We can continue with our hot water here. We've got our cold. We had a stopper, and I saw some students in class take their stopper and they pushed it in there good. They took the tube and they stuck it into the stopper, jam it in there. I'll put it in the stopper and then stick it in the bottle. So I think it's in there pretty good. It needs to be airtight so that the gas doesn't sneak around the sides. And then I saw some students going like this. They took some bubble water, water with soap, and they poured it into a container. And since I can have all this hot water, they went like this. They put this in the warm water, and they stuck this into the liquid, and the bubbles start coming. Why is that happening? Well, the particles inside of the volume, inside the plastic water container, are being heated up, and there's only one way out. The only way out is the end of this, and you can still see the bubbles coming. The only way out is through the plastic tubing. So this is an example, demonstration of what happens to a volume of air when it is heated. So I'm wondering what will happen now if we cool this air. If we cool it, let's see what happens. Put it in the cold water. Well, now I see liquids being pulled into the volume or the plastic water bottle. Okay? So that's another demonstration that would work for this short lab. So watch this video and make sure you understand the answer to the question that I posed to you at the beginning of this lab. Okay, so that was the video of the lab that we did. And I talked about the particles of air in the water bottle. So let's take a look at what they may look like if we had to draw the particles. So if that's our volume of air, and we'll call this room temperature, room temp, let's put in 10 particles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Say we have 10 particles at room temperature. Well, let's draw the same volume as close as I can, and we'll call this volume of air the heated up, the heated volume. Okay? So we still have our same 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No new particles are made. Particles are not created because it's matter. Gas is matter, air is matter. So we still have 10 particles, but something's happening when we heat, when we add heat, and we got our heat from the warm water, the hot water. The container, the water bottle, started to expand outward. It's because the particles gained kinetic energy. Kinetic energy equals they gained motion. They moved faster. They didn't get bigger. There wasn't more particles. They just gained kinetic energy. They moved faster and they were trying to escape. So at the other end of the spectrum, if we have the same volume and we cool this volume, cool the volume. We have the same 10 particles. What happens when you cool? You remove, minus, you take away kinetic energy. So what that means is you have less motion. So what that means is all those 10 particles, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, there's still 10 particles. They haven't shrunk in size. They haven't disappeared. They're moving at a slower speed. So I like to say they're clumping together. So what's happening is they're allowing for the air particles outside of the water bottle. They're moving at a faster speed. So they're slamming into the water bottle, causing it to implode or contract. Okay? So this is contract And over here when they're heated, it's expand. Okay, so that's the visual on what you saw in the short video I just played. Okay, so one last thing I would like you to do is, if you would, go to youtube.com and in the search, so you put on the little magnifying glass, search, I should have written it here, 55-gallon drum crush. 55-gallon drum crush. Check out the short video and then ask yourself and answer, how does this video relate to what we just investigated in class? Okay, so this concludes the video, the end, and your job now is to complete page 32 and page 33 of your science spiral, the lab that we just did. You have all the information you need, and you can complete that with the partners that are in your group. Use complete sentences, use good grammar, proofread your work. Make sure your drawings are accurate and neat. Do your best work.